What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. Today, we're talking about sweet science. What time is it? It's science time.
Hi everybody, my name is Mr. Gummy Bear and welcome to DIY Science Time. I'm so glad you're here to be part of my Gummy Bear crew today. We're all so sweet.
Oh, hi everybody, it's Mr. C from DIY Science Time. I'm so glad that you and our gummy bears are here to be part of our science crew today. I'm so excited about this episode today. It's going to be so much fun because it's so sugary and so sweet and so
Delicious.
That's right. We're going to be talking sugary science, and most importantly, we're going to be doing a couple of activities that you can follow along with at home also. So, gather a couple of materials and let's get started.
Yay! Let's get started! Woohoo!
You're going to need these materials: a plate, Skittles, M&Ms, or other hard-shelled candy, some water, and don't forget your super sweet science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
For this next experiment, we're going to be using some hard-shelled candies and also some water and some plates to design some amazing sugary art. Let's give it a try. Here's what you're going to do. You're going to create your own pattern on a plate. Then we're going to pour some water on it, and we're going to see how the water and the candy react to one another. All right, so any pattern works. You can make one like mine or be creative and make your own. All right, so my pattern is I took 7 of each color and I just made what looks like not a circle, but it's close. But what I'm gonna do is I'm gonna take this water, I'm gonna pour it into the center of this, and I'm going to try to cover half of the candy with water. So it's kind of submerged, but it's not completely submerged. And now we're going to wait just a moment to see what happens. So let's observe. Oh my gosh, look at it going already. They all seem to be moving at about the same rate. The sugar is dissolving into the water. And that diffusion, it is moving through the water. Oh, magnificent. That is amazing. That looks so cool. All right, we have to try it again with another pattern. I'm gonna try to make a flower. I wanna see what that looks like. All right, so I wanna make like a sunflower. All right, let's see what this does. I have no idea what this is going to do. Pour it into the center. Be careful not to shift your pattern. I'm not sure what this is going to look like. That looks pretty cool. Oh, look up here. It's like a rainbow. It's like coming down, shining light onto our sunflower. Grow, little flower, grow! Photosynthesis! Ah! The sweetest part of these experiments today is the sugar. Did you know that the chemical name for sugar is sucrose? Sucrose is a molecule composed of 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Like all compounds made from these three elements, sugar is a carbohydrate. It's found naturally in most plants, but especially in sugarcane and sugar beets, hence their sugary names. Sucrose is actually two simpler sugars stuck together, fructose and glucose. If you look closely at dry sugar, you'll notice it comes in little cube-like shapes. These are sugar crystals and are an orderly arrangement of sucrose molecules.
Candy has been dated back as far as 2000 BC. These candies found in ancient Egypt were made from honey mixed with fruit or nuts. That's a long time ago, but it still sounds pretty yummy to me.
This next activity is really cool also, and what we're going to be doing is using some soda pop to pour it into a cup. Now I want you to pay attention to this. When I pour the soda into the cup, see all of those bubbles on the side? That's carbon dioxide. It's grabbing onto the cup because the cup, although it looks really smooth, it's not perfectly smooth. The carbon dioxide wants to grab onto things, and when it does, it bubbles up. So what we can also do is we can take a little bit of vegetable oil, and I'm gonna just roll this around. I'm gonna line the entire side. Get the sides covered really good. I probably have too much in there, but I'm gonna get this lined. Whoops, ooh, I put in my soda. I'm gonna line this up, and then I'm just gonna pour the extra in here. This is my science vegetable oil, so I don't use this for anything else. Now, we're gonna pour the soda in here, and we're gonna see if the same thing happens. Oh, that's really cool, right? On the sides, there were literally no bubbles. That's because the vegetable oil kind of gives it like a covering, and it makes it really smooth, and the carbon dioxide has nothing to grab onto. Now, you might be wondering, wait, this is a show about sweet science, about candy and things like that. Absolutely. So that's why we have this candy here. This white hard-shell candy, it's a Mentos. This little guy, when you put it into soda, well, let's see what happens. Creates lots and lots of fizz. If I put 2 or 3 in, we get all of this fizz that starts happening. And that fizz is the carbon dioxide grabbing onto that Mentos. That Mentos has all these little teeny tiny divots, nucleation sites. And what happens is the carbon dioxide grabs onto it and it fizzes just like that. Well, we can have a lot of fun with Mentos and soda if we are creative and if we dump some of these into this. Now that we saw what happens when we put Mentos into soda, we're gonna try to put the Mentos in the leftover soda because we don't wanna be wasteful. We don't wanna waste our soda, right? So I have an experiment we wanna try. Putting this in there is probably gonna cause a reaction. So we're gonna try to control it with this contraption. We're gonna drop Mentos through a tube into the soda, but we're going to hopefully control how the soda reacts by having these release tubes, right? So it can, if something happens, it's gonna go up and it's gonna push out, and then we're not gonna spray soda all over the house. If you try this, take it outside and give it a try outside with your science crew. Don't do this one inside. What we're gonna do first, we're gonna take a couple of Mentos and put it into our tube, and this tube is going to be our release mechanism. I have some magnets holding some steel bearings in there, which are going to keep everything in place, and when I pull this, steel bearings and the Mentos are gonna fall into the soda. Now I'm going to put this here, connect this, tighten it up really good, and then I'm going to spin this on. Whoa. Whoa. Want it nice and snug. There we go. All right, we have it nice and snug. And now, because I'm anticipating something is going to happen, I'm gonna put some cups here. Hopefully I have them lined up fairly well. I'm super excited. In 3, 2, 1. That was awesome. That worked perfectly. That is so cool. Oh my goodness. That is how you pour a bottle of soda for friends and family when you're doing science at home with your science crew. That sound though, that was so cool.
I've got an engineering design challenge for everyone. Can you create a structure that is 24 inches tall using only gumdrops and toothpicks? First, design your tower on a separate sheet of paper. Think about shapes you've seen in buildings and structures where you live. What type of geometric shapes are used to support those structures and give them strength? After you've created your initial design, grab enough toothpicks and gumdrops and start building your tower. Did your design work? Does it need improvements? What could you do next time to make it stronger or make it taller? Give it a try and share your tower creation online using hashtag #DIYScienceTime.
What do you call a sheep covered in sugar? A candy bar. I never realized that table sugar was actually called sucrose, and that it's made from glucose and fructose. And what about those Mentos experiments? I wonder if changing the number of Mentos or the size of the soda bottle would change how high the soda flows.
Speaking of marshmallows, did you know that these white fluffy snacks have thousands of pockets of air inside of them? That's what makes them so soft and squishy. But I wonder if we can expand and compress the air inside of those marshmallows. Mr. C has added lots of little marshmallows to this bottle. When he attaches this soda pump, he can push extra air into the bottle. You can see the marshmallow squish and collapse as he pumps in more air. The extra air increases the pressure inside the bottle and squeezes all those tiny air pockets inside the marshmallows. The marshmallows try to bounce back to their normal size when he releases the pump, because the air pressure inside the bottle returns to normal. Now try placing a marshmallow into a plastic syringe. Cover the tip with your fingers so air can't enter the syringe and then pull. The air pockets in the marshmallows begin to expand and grow. When you let the air back into the syringe, the marshmallow tries to go back to its original shape.
For this next experiment, find your favorite gummy treat. I'm gonna try the experiment with gummy bears myself, but worms could be great to try also. Grab 5 clear plastic cups and fill each with a different liquid. Tap water, salt water, milk, soda, and vinegar. Place a gummy bear into each cup and give them a long time to soak overnight. Check out the size of these gummy bears. Gummy bears don't actually dissolve in water. They have a semi-permeable membrane. This means their surface has holes in it. These holes allow small, non-charged particles like water into the gummy bear. But don't let larger particles like the sugar the bears are made from back out. The gummy bear is a solute and the water molecules are a solvent. Water moves into the gummy bear through osmosis. Can you think of any other liquids in your fridge you might want to test and see if they allow your gummy snacks to grow?
This next activity is really cool. Well, actually it's really hot, so you're going to want to have an adult with you for this. We're making sugar stained glass using a recipe that I've had for quite some time. Recipes are awesome because they're a fun way for scientists to do things over and over repeatedly and share that information with others. Just like I'm going to share my recipe with you, you'll be able to share that with your science crew as well. So first things first, we're going to need 2 cups of water. Pour it into our container. I'm going to get this turned on right away so it starts heating things up. And now we need 3.5 cups of sugar. That is slippery. 1, 2, 3, and 1/2. That is a lot of sugar. Oh my. Whoa, I'm gonna slide this over here, just right there. We're gonna get this stirred up. So I'm gonna keep stirring. And stirring. And stirring. And stirring. The sugar and the water is mixed together, but we're also going to add some corn syrup to our solution. So the recipe is calling for 1 cup of corn syrup. And corn syrup actually prevents this solution from crystallizing again. It's going to prevent it from just turning into a crystal. I think we're in a sticky situation. We're also going to need to add a 1/4 teaspoon of cream of tartar. That's a fun word to say. Cream of tartar. The cream of tartar is going to keep the sugar in a simple form, so it allows our candy to do what it needs to do when we're making the stained glass solution. All right, here we go. Our solution right now is only at 100 degrees Fahrenheit. It's going to take a little bit of time for this to actually get heated up to the right temperature. But in the meantime, enjoy that sweet, sweet swirl. We just passed 150 degrees Fahrenheit. Boiling, here we come. That's 212. We're almost at 200 degrees Fahrenheit. I need to get my stuff picked up here so that we can get this poured out in just a little bit. All right, let me get cleaned up. Now 300 degrees is the temperature that we're going to pour it out at. And we don't want to keep it in there too long because at 340 degrees Fahrenheit, this will start to caramelize. We're finally here, we're finally here. All right, let's turn you off. We're at 300 degrees Fahrenheit. I'm gonna pull this out. Bring this over here. I'm gonna pour. Whoa. This is very hot. My pan over here, turn off my burner. And now, what I'm going to do is I'm going to add some coloring to this to make it look like stained glass. I also have a craft stick, or multiple craft sticks, so that I don't have to mix my colors. I'm wondering though if these bubbles will go away. All right. It's literally still boiling. It's so hot. But here we can see that it's starting to cool. Let's add some coloring. Oh, that's so cool looking. I'm gonna add one there, 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 and there. I'm just gonna stir it a little bit. Not sure how fast it's going to cool. In just a second. I can feel it starting to cool. I'm gonna add some red. Oh yeah, you can see it's cooling. Just want to make this into like a line. I'm just gonna go through it. All right, so we're gonna let this cool now, and then we're gonna come back to it after it's cooled to see if it actually can be lifted out like a piece of stained glass. And I left these two parts here like this without any color because I wanna see what that might look like with the light coming through, shining through that part versus the other part that I've added color to. All right, let's let it dry. Well, let it cool. Now that everything is cooled off, we can handle this. And what's important to know is we let it cool down for a long time. Not only was it unsafe to handle it while it was too hot, but it also allows the sugar to form and get hard like this. And because we added the cream of tartar and we added the corn syrup, we get this really smooth sugar candy or stained glass. I'm going to try to actually take this apart in one big piece. I'm not sure if it's going to work, but we're going to give it a try. And if it breaks, that's okay. All right, here we go. I actually got two pans here. Right. Oh, it's already cracking. I wonder if I took a pair of scissors. Yeah. I'm gonna grab some scissors. Oh my gosh. Oh my gosh. Oh my gosh. That is amazing. Look at this. Stained glass. And the colors look so cool. Oh, look at this on the back. It has the texture from the pan. Oh, that is so cool. You can hear it. Smooth on the other side. Now, I'm gonna see if I can see you through it. No, I can't see you through it. That means that this is not transparent. So what's happening is this is translucent, right? So the light is able to get through it. I can see light coming through it, but it's not clear, so it's not transparent. This is translucent, and it's not opaque because opaque, creates a shadow. And opaque doesn't let any light come through it. But there you go. Give this a try. This is the coolest thing I think I've made in a long time. This is so cool. Stained sugar glass, made at home with my science crew. So cool.
The average American consumes almost 152 pounds of sugar in 1 year. This is equal to consuming 3 pounds or 6 cups of sugar in 1 week. I hope our toothbrushes can keep up.
Nom nom nom. You know how I know our science crew is so sweet? It's because they always help each other out in a crunch and are always finding amazing new facts and information about sweet science topics. I added the recipe for making stained glass to our notebook. Making sweet treats with your science crew is always a fun way to explore sugar and its properties. Plus, the artwork you can make is beautiful and delicious.
Hey, Mr. C, you did a great job today.
No, you did a great job, Mr. Sugar Bear.
No, really, you did a great job.
No, you are the best. You're the sweetest little bear I've ever worked with.
Oh, you're right.
Our little bear did a great job today. And all of us did a great job today because we had such a sweet time doing sweet science. Whether it was the stained glass, whether we had our marshmallow pump, compressing those marshmallows, or even our Gumdrop Towers. It was so much fun. And remember, if you haven't done so yet, record all of your data in your science notebook. This notebook allows you to keep track of everything that you've done so you can go back and check it out in a future date. Having a notebook allows us to be great scientists because we can record our data and keep track of everything. Oh, so much fun. I can't believe it's over. What a sweet, sweet day, right? Well, guess what? I want you to keep exploring. I want you to keep learning. I want you to keep having fun. And I want you to remember that science is wherever you are. Take care, everybody. Bye. One more time.
It's science time. It's science time. It's science.
Now that that's, what am I trying to say?
It's science time. It's science time.
Give it a try. And the cream of tartar. And the cream of tartar. I can't say it. And the cream of tartar. Well, it's actually really hot, and that's why you're gonna want an experiment. Tartar or tartar?
We know it's awesome. We know it's great. It's science time.
The cream of tartar. It's tartar, isn't it?